Okay, we're going to move on to our next operation. We're going to multiply our complex numbers. Part A, we are missing an I, so instead of negative 2.5, that should be negative 2.5i times the complex number 8 minus 9i. So to multiply complex numbers together, it's going to feel like math you've done before. This is going to be distributing. We're going to multiply 2.5i times 8. So 2.5 times 8, I'm sorry, it's a negative 2.5, is a negative 20, and then the I just carries along with it. Then we're going to distribute to the second term. We have a negative times a negative, so that term's positive. 2.5 times 9 is 22.5. And then we have I times I. I times I is I squared. Now, let's make a note with a big star. I squared has a value of negative 1. So anytime that I squared shows up in our work, we're going to replace it with a negative 1. So what that means is our negative 20i stays the same. Plus, instead of 22.5 times I squared, we're going to do 22.5 times negative 1. That gives us a negative 22.5, and now it's a real part of our complex number, so that's going to go first. Negative 22.5, and then this minus 20i will go on the end. And there's our answer from distributing that. So let's talk for a second about that I squared equals negative 1. We defined I as the square root of negative 1. Well, if I want to know what the value of I squared is, I can square the I, which means I have to square the other side. So I square an I get I squared. The square of a square root cancel each other out, and I am just left with a negative 1. And that's how we get that I squared is equal to negative 1. So anytime you multiply two i's together in your work, you will end up replacing that with a negative 1. All right, part B. We have a complex number times another complex number. Ultimately, it's a binomial times a binomial. And when we multiply this out, we're going to FOIL that. FOILing is just distributing. So we will start by multiplying the 3 times the 3. 3 times 3 is 9. Then we're going to multiply 3 times a positive 2i. That's a positive 6i. Now we're going to distribute the negative 2i. So negative 2i times 3 is a negative 6i. And then negative 2i times a positive 2i is a negative 4. I times I is I squared. So let's combine any like terms first. We have a positive 6i and a negative 6i. Those actually do cancel each other out. We're going to carry down the 9 minus 4i squared. So there's that I squared that showed up in our work. We're going to replace that with a negative 1. So we have 9 minus 4 times, instead of I squared, it's times negative 1. So we have 9, and then this is a negative 4 times a negative 1. Negative 4 times negative 1 is a positive 4. And 9 plus 4 gives us a final answer. This simplifies down to just a 13. When you combine like terms in the middle like this, they don't always cancel. They will cancel if you are multiplying complex conjugates. So let's define what a complex conjugate is. Complex conjugates are complex numbers with equivalent real parts and opposite imaginary parts. Their product, if you multiply complex conjugates together, will result in a real number. So their product is a real number. So, for example, complex conjugates, let's say I have 7 minus 8i. The real part stays the same, so the 7 stays the same, and then the imaginary part have opposite signs. So instead of minus 8i, we have plus 8i. So these are complex conjugates. Let's see another example, negative 2 plus I. So the real part stays the same, negative 2. The imaginary part will be opposite. So instead of plus I, it's going to be minus I. So these are complex conjugates. If you notice up here in part A, we have 3 minus 2i. We multiplied it by a 3 plus 2i. So these are complex conjugates. When we multiplied them out, we ended up with their product being a real number in the end because we did end up with the middle terms canceling out. That will happen every time you multiply complex conjugates together.